All right, I love shortcuts, and today I have a shortcut for you that I think will help with your subwoofer alignment. So I'll try to give you the quickest possible explanation here at the beginning, and then you can decide if you want to stick around for the longer explanation for the rest of the video. So the quickest explanation is that if you have a sound system like this, you don't need to take measurements anymore, distance measurements, if you're doing the relative absolute method for subwoofer alignment. So if that interests you, but none of that really made sense, then let's stick around for the rest of the video and I'll get into explaining why. But if there's any questions that I don't answer, please feel free to comment on this video. I'll answer them there. That'll help me make better videos in the future. Okay, what am I talking about? Well, if you use the relative absolute method for subwoofer alignment, like I do and have been doing for a few years now, then when you're doing that in the field, sometimes the most challenging part can just be getting that distance measurement. And so if you can't get that from a design, then you are getting that with a laser disto or something similar. And if you're outdoors in the sun, maybe you've seen my other posts about this. I have a bunch of tips for how to do this outdoor in the sun. But it's still kind of a pain in the ass, basically, right? If you don't know what I'm talking about, there's this article over here. This, I feel like, is a good introduction to the relative absolute method because although it links to Merlin's article here, relative absolute method, here I basically give some evidence for why it's important. So if you want to click over here, you'll see Merlin's article where he explains it, and I'm using his name for this method because all of these manufacturers have slightly different names for it or no name at all. So I'm calling it the relative absolute method like Merlin does, and there are a bunch of manufacturers that recommend it, and so you can take a look at this article if you're not familiar with that yet. But my guess or my hope is that you're already familiar with this since I've made several other videos about it in the past. And I even have a product called SubAligner that leverages the relative absolute method to help you do alignments. So I hope this will be helpful to SubAligner users as well as everybody else who uses some other method, maybe Excel, spreadsheet, calculator, whatever. This is from my book, my ebook, The Complete Guide to Measurement Microphone Placement for Subwoofer Alignment, and it comes from this chapter called System 4, Center Ground Sub Vertical plus Horizontal Displacement. And that's basically just a long title for center placed subwoofers. So this is super common design, especially in my world. I'm always trying to get a center placement for the subs. I think a lot of you out there are doing this as well. And then the question always comes up, how do we do the alignment? Where do we place the microphone? Because we have all these planes of asymmetry now, vertical, horizontal, everything, right? So a while back, I guess in 2017, Merlin published this article called Where to Time Align Center Sub. And I think he and I were chatting about it around the time, and then I made a video about this. And then there have been some other discussions about this, but so this chapter of the book is basically the same thing as this article. It basically just talks about how to find the position for this zero offset line. And so what Merlin recommends here in the article, and the same thing I recommend in the book, is that you use his method or any method to find this zero offset line and then do your alignments there. Now, what took me years to realize is that zero offset line means no distance offset. So you use this method to find the point in the audience where the distance to here and the distance to here is the same. Now, you may have already known that already, and I thought I knew that, but what I only realized recently is that just by the sheer existence of that point in space, in the audience, means that we don't need to do distance measurements, right? So you only need to do this distance, you only need to do a measurement here and put your microphone here if you don't know the pre-alignment delay values. And you will not know the pre-alignment delay values if you are, using especially speakers from different manufacturers because they don't publish those, and maybe you don't have access to SubAligner or whatever. There's lots of situations where you don't know those values, but there are lots of situations where you do. Anyway, sorry, that's kind of a tangent. The point is that I've just kind of realized that zero offset line means zero offset line. So that's the first step here. And I'm going to go in and show some more details of this because I had to do some of my own tests to kind of prove to myself that this works. And so I'm going to show you those and show you how you can do the test yourself and practice yourself with, all in software, or you could set up some tests at home. But the ultimate result here, just to bring it back to the whole proposition of this article and this video, is that if you have this kind of sound system, just because this position exists, there is a zero offset line in the audience. And there may be some situations where that doesn't exist, but I'll talk about those later. But most of the time, there is going to be a zero offset line in the audience, and therefore, if you know the pre-alignment delay values of your speakers, then you don't need to take measurements anymore, and you already have all the information that you need to do your subwoofer alignment. And then you are free to move on to other things and verify that with your audio analyzer later, or whatever your workflow is. Okay, so I showed you Merlin's article, take a look at that. I showed you my article, take a look at that. And now let's get into Map 3D. So here in Map 3D, I have a couple of what are called omnidirectional sources. And these are super fun to play with because it's basically just a microphone cable is the response, just perfectly flat magnitude and phase. And you can put them wherever you want and just see how two perfectly omnidirectional, perfectly flat sources interact without any reflections or any walls or any of the other things that usually, make up a speaker response. So maybe I can just give you a quick demo of that. And we'll go over here to the measurement viewer. There we go. So there's your flat response. I don't know exactly why they make it tilt off the end here. I did look in the Map 3D documentation, so I don't know the answer to that. Maybe I'll find out later. But there's probably some good reason for that. But otherwise, you can see flat magnitude, flat phase, just a test element here. And the reason that I want to start with this is because whenever I'm doing any tests, I want to start with the simplest possible test. All other things being equal, what can I change? So you see that these are both basically at the same position, except for this offset in the y-axis. So let's put an audience in here. And let's make that audience a prediction plane. And let's zoom out to the extents of the audience. And now let's think about Bob McCarthy's triangles from his book. Let's think about isosceles triangles. And so if I draw a line here and then try to guess where the center of that is, maybe about here, and then I draw a line up here, then this is where I expect summation to be in the audience, right? This is the isosceles triangle, anywhere along here. Okay, and so I should be able to hit predict and see that come true. And there we go. So there's that line. You see that I didn't draw it exactly in the middle. I've got a little microphone here that is in the center though, and so we can see that it's in the middle. And let me just make sure that I have all my, there we go. That's why it's off a little bit. So I had a little bit of a delay in there from some experiments I was doing earlier. There we go. Now we can see it's in the center and my microphone is also in the center. What I want to do is just make some little changes here Because I think we all accept this as true, right? The farther we move this source in this direction, this line of summation will also just move this way, right? So we can just test that real quick to make sure that things are working as we expect them to. So right now we're at 20 meters. So what if we go to 30 meters, and I'll leave myself some breadcrumbs here. "30 meters, predict," and there we go. So just confirming that I have my kind of test set up here and I kind of know what's happening. The whole pattern just shifted this way. Okay, so let's go back to where we were before. Okay, so here we are back in the center. So I've tried to, I can see what happens with with Y offsets. I'm looking at this little guy down here. So we tried Y offsets. Now what's going to happen if we do Z offsets? So if I make the speaker just go higher. And this is where things start to get interesting. I want you to think about what you think is going to happen for a second while I'm making this go higher. So I'm going to make this go up 5 meters in the air. Okay, so there it is at 5 meters. Just prove this to you real quick. You can see it's up a little bit higher now, but let's go back to a top view. That's what we're familiar with. And that's where our center line is. That's where it was before. So where do you think it's going to be now? So I'm going to hit predict. Okay, and it looks like it moved over a little bit. Not very much. Let's make it go farther. So how does that compare with what you thought was going to happen? Okay, so here we go. Interesting for me is that it's still pretty much a straight line. So I'll make this a different color. And there we go. Now let's make it go even higher. So we went to 5, 10, 15. Okay, so we're just moving right along here. 20 meters. Okay, and I can tell you from running some tests, and I recommend that you do these tests as well to kind of prove this to yourself, that this pattern just keeps repeating. That this line that I'm marking here, the zero offset line, will just keep moving in the positive direction on the y-axis until it goes out of the audience. Now, is that going to happen in our audiences? Probably not, unless we have a very narrow audience and our speakers are very high. So you should probably look at that. But most of the time, our audiences are wider than our speakers are high. And so I don't think we have to worry about that as much. But let's just take a look at an example. Let's go up to, I don't know, should we go to 30 or 40? Anyway, you see it going way over here, right? So you kind of see, just so interesting for me that this pattern, though, of this straight line, the zero offset line, maintains. This is what is the really valuable piece of information to me, because it doesn't matter how high the speaker is. We could change the speaker height all day long. This zero offset line still exists. And if this zero offset line exists, and I know the pre-alignment delay values, that's how you do the absolute relative method, right? You need the absolute and the relative part. So as long as we know the relative part, and we know that there is a point in the audience where we would take our measurements that is the absolute part, and that absolute part is 0 because there's 0 displacement at the zero offset line, then our alignment's done. So we just need to know that we kind of understand this geometric relationship here. Okay, so we looked at some Z offsets, and I think that was really interesting, but let's go back to 0 here. And let's make sure that we are at our original position. Here we are, this line here. And you know what, let's get rid of these other lines. In fact, I'll just draw a new line. what do you think is going to happen if I move this speaker this way? Okay, think about that. So I'm going to move this on the x-axis minus something very small, 1 meter. Just 1 meter. Now think about those shapes we were drawing earlier. Think about that isosceles triangle. If we now have moved this a little bit, so that now instead of that line going down here, now it's just going a little bit like this, then it won't be that big of a shift here, but by the time we get to the back of the audience, we will have shifted over a little bit more. So let's take a look at that. And there we go. So not exactly like I predicted. I should have left that other line there. Sorry about that. But there you go. You can see that the line is shifting off to the left there. And so you can imagine that if I were to go farther this way, that the line would shift farther this way. And if I were to come and reverse the other direction, the line would shift this way, right? Let's just do those really quick so that we feel like we're all on the same page. Let's go back 5 meters. There we go. So now this whole thing has shifted over to here. There's our 0 offset line. And let's just do a quick test in the other direction. We'll go forward 5 meters. And let's just see, we expect this direction, right? And there we go. Okay, so how do we fix this problem? Maybe that's fine with you, but in this situation, we're talking about kind of solving that problem so that we always have this 0 offset line going from front to back of the audience. Why are we doing that? That is covered in this article. So that's kind of out of the scope of this video, but this is our intention, and if this is the result that you want to achieve, then that's what we're talking about. So let's take this guy, let's move him back 1 meter again. So we'll put in -1. So if this guy is now going to be 1 meter late, and that means that our 0 offset line has been tilted, then what do we need to do to untilt that line so that it goes back this direction? So we could move the speaker again, but just talking about electronic resources like delay, we don't have a pre-delay to pre-delay this back this way, but we can delay this guy so that it's also 1 meter late. 1 meter is about 3 milliseconds. So let's just go into our processor here and let's mark this so that we can see the change. So here's the current 0 offset line. We'll put in 3 milliseconds of delay into this center guy. Okay, and now we have untilted our line. So now we have this line just like the original. And what's really interesting about this is that this guy can be really far off. So we could send this back 20 meters. Let's go -20. And then we'll have this really weird line that we might not even be able to see. Okay, so now we have this really weird line that I'm not even quite sure where the 0 offset line is anymore. But if I just do a quick calculation and say, what's 20 times 3? I'm not very good at doing math live, so I have to type it in here. 60 milliseconds. And I go back over here and put in 60 milliseconds. I'll tell you right away, it's not going to look pretty, but we're going to get that 0 offset line back. Okay? So there it is, right there. And it's not perfect because I'm doing an estimation by just multiplying the number of meters by 3. But so interesting, right? That we can have kind of any offset in the vertical plane on our Z axis, and we can have any offset in the X axis, and we can just account for it with delay to get back to pretty much our original situation. Okay, so we looked at some experiments here of just moving some things around. Let's look at how we can solve this in the field, and then we'll look at some real speakers. So let's undo the things that I did. Here's 0. And I'm calling that little guy our main. Okay, so I'm going to leave him at 20 meters in the y-axis. Let's see if we're back to where we were before. Okay, here's our original situation. So let's set this up sort of similar to how it might be on a show. So we will add some amount of z-axis offset here, 10 meters up in the air, and then let's say that our stage actually is right here. Do I have a stage? I never drew that in. That's okay. And we'll just add some positive value here, like 1 meter. Not in the z, sorry. Not in the z, but in the x. Because we saw earlier that just adding a little bit of offset, if they're not, the same depth compared to the audience, is going to tilt our 0 offset line. And I have a microphone placed already that represents where we want them to be aligned. That's where our 0 offset line is, right? And so now what we can do with SubAligner is that we don't even have to take these measurements anymore. Let me show you what I mean. So over here in SubAligner, normally what you would do is you would select your preset, and then you would go ahead and fill out your distances. And so we might measure our distances here, and we would say, okay, from our microphone to our main, our first source is 60.94. Wow, I wish they would make those numbers bigger. 60.94 meters. And to this other source, let's hide that audience. To this other source, where is my microphone? 59.36. 59.36 meters. And you can see that they're very close. They're only about 1 meter off. So then we hit align, and we can see that we need to delay our second source, our sub, by 4.58 milliseconds. And that passes the gut check because we know that the sub is closer. We know that it needs to be delayed. We know that it's closer by about a meter. We know that a meter is about 3 milliseconds. So 4.58 milliseconds is not too far off from our expectations. Also, little changes of the measurement are caused by where you actually measure on the source. So you can see that you can grab its measurement from a lot of different faces around the Omni source. So I may have not picked it right on the face, Okay. So that's how you would have had to do it in the past. You always have to get these distance measurements, and if you have a design like this, it's simple, right? You just look at these sources and you say, hey, where are you in space? Tell me your X and Y coordinates, or tell me your distance, or you just use a distance measurement tool. When you're in the field, it can be a little bit more complicated when you have long distances or sunlight, or you're in a hurry, or you're under a lot of stress, stuff like that. So what can you do now? Well, when you choose a preset, now you are taken to this select an alignment position page. And if you select the center subconfiguration here, and there's just a little image here to show you give you an example of what this looks like. Now you only have one field to fill out. And the only piece of information you need to know is basically the location of the subwoofer. And so here it says sub depth relative to mains on x-axis. Let me know if you can think of a simpler, more clear way to say that. Basically, you need to know the x coordinate of this source here. So you can see the x coordinate is 1 meter. And so I would put in 1 here because the sub is in the positive direction here on the x-axis. And so it would be -1 if it were this way. So this makes an assumption that you're kind of familiar with 3D design software, and that the center of your design, the 0, 0 coordinates, are relative to the mains. So that's why this placeholder here says sub depth relative to mains on x-axis. It says that the mains are at 0 and the subs are 1 meter in the positive direction on the x-axis. Okay? So all I have to do is put in 1 here and hit enter, and then all I have to fill out are the totals. I have 1 of each element, and then these become read-only fields. You can't even change them anymore because the values have already been filled out for us because we put in information in that previous page. And so now I can just hit enter on this, and now we get to this next page where our 1 meter offset has been converted to 2.9 milliseconds of delay. And so now over here I could go to our output processor, put in 2.9 milliseconds of delay, hit predict, and we can see that we've got our nice 0 offset line here without it being tilted. Okay, that is pretty simple when it comes to just these Omni sources. Let's do some speakers. Maybe we should do one more test. I feel like I made that explanation a little bit wordy. And so I want to make this really clear. You can see here that this is our main, and you can see here that this is 0. And so I'll zoom in here, and you can see that relative to 0, our sub is at positive 1 meter. Okay, and so I'll move it around a little bit just to show you. This is positive 2 meters. It's going into the audience, positive values. Away from the audience, negative values, right? And so now we could set it to -2. And so now, based on this 0 line here, if the sub is actually farther away, moving negative on the x-axis, then over here, I would put in -2 for this field. Sub depth relative to mains. So now the depth is at -2 on the x-axis. And now when I submit this form, again, it fills out these distances for me. And now we'll convert this to delay. And you can see that now there's no delay in the subfield anymore. This makes sense, right? Because now it's the sub that's farther away, so it's the main that needs to get delayed. How much delay? 5.8 milliseconds. So we go back to our output processor. We hit predict, and we should get that nice 0 offset line back here. Okay. So I've used this in the field a handful of times now. It's super nice. Most of the time I can just walk over to the sub. I can look at how it's lined up with my mains, take out my laser disto or just a tape measure or something, and see, Are my subs perfectly in line with my mains? Therefore it's 0, therefore I don't need to do anything, right? I can basically just put in 0 in this field and have that handled for me and just have some confidence that SubAligner is doing this for me. Or I measure that offset and put that in there. Okay, so we played around with Omni sources a little bit, but let's look at some real speakers. Will this work with real speakers? So let's hide our Omni sources and let's look at some speakers. I put in some tiny speakers here. Again, just trying to take the next smallest step, not like a full arrays where things are going to be complicated, but just the next smallest step here. So taking a look at the isometric view, we can see we have a subwoofer here, a 750 LFC, and an X42. And so let's just take a look at these without doing anything yet. Just out of curiosity, what if I told you nothing? What would you expect here? Let's say that, you know, Meyer Sound does not publish any kind of preset guide. They have their own solution of loading presets for handling this, but what if you didn't know anything, I didn't tell you anything? What would you expect here? Let's just make sure I have all these delay values cleared out. And let's do a quick prediction here. By the way, we're looking at 80 Hertz. I don't think I mentioned that before. And let's, you know what? I think I took too big of a step. Let's actually put that main speaker on the ground before we take it up in the air. Okay, now adjust your expectations. Okay. Okay. So here we go. This 0 offset line here it's looking pretty good, but I don't think it's perfectly straight, right? Like this would be perfectly straight. It's a little bit off. And so we could go in here and place our measurement microphone and do the alignment, but we're trying to think about how to do this the relative absolute method way. So we need to know our pre-alignment delay values. And so there are various methods for getting that. I'm going to get that from SubAligner. So I go in here and I'm going to select my main. I believe it was X42. And I don't have anything, just going straight into the speaker. And then the Meyer Sound 750 LFC. Okay, so here we have our one choice to make, and I haven't done any offsets in the x-axis yet, so this will be 0. And we just want to get to the next screen to see the pre-alignment delay values, and we see here, oh, we need 1.1 milliseconds delay. Seems like a trivial amount, but apparently that was enough to make this tilt off to the side a little bit. Okay, and so if we put in that 1.1 milliseconds of delay, that'll basically delay this guy back a tiny amount and should untilt our line of summation there. So 1.1 milliseconds of delay, predict. There we go. So we're back to having a straight 0 offset line there. So now let's do some experiments here where we actually change the position. We've got our pre-alignment delay value loaded, but what happens when we have some changes here? So think about the things that we've talked about so far. What changes in geometry really matter here? What offsets really matter here? So if I switch over to our X42 and I say, you know what? We're ready to take this up in the air. Let's go up to 10 meters. What do I need to change? So from what we've talked about so far in the tests we did, if I change something on the z-axis, what do I expect to happen? This is where we were before with our line of summation. Do I need to do anything? Well, if you remember the test we did with the Omni speaker, we saw that we could basically move the speakers up and down on the z-axis all day long. And yes, that 0 offset line is going to shift up on the y-axis, but it'll still be straight front to back. So I don't need to do anything else. My job's already done. The only thing I need to worry about is if either of these sources are not the same depth anymore. So let's do the same thing we did with the previous test, where this is going to move into the audience a little bit. So if this ends up getting moved into the audience by, let's say, 1.56 meters, getting a little bit more complicated here. Now we have we want a positive X value on our subwoofer of 1.56 meters. So that means we're going to have to come back over here, and on the alignment position page, we'll put in the exact same value, 1.56 meters, for our subwoofer depth relative to the mains again. And then when we get over to the results, we see that, okay, now the delay has shifted from the main into the sub. And this passes the gut check because our subwoofer is closer to us now, and so it would need to be delayed by 3.42 milliseconds. So I go over to our output processor, I take this delay out, I put this delay in, and we expect to see that 0 offset line return. Okay, so I should have drawn in that new line last time, but there we go. There's our 0 offset line restored. So I think I'm going to wrap it up now. I feel like this video's gone on pretty long, but I really recommend that you get into your favorite modeling software and do some of these tests yourself. It was really fun and interesting to move all this stuff around and to see what changes produced what results. But at the end of the day, this produced a really helpful learning of a really helpful shortcut for me and my work. And now I know, anytime I get into the field and I have a sound system set up that looks like this, where I have a sub in the center, I know that all I need to know is the subwoofer depth compared to the mains, as long as I know the pre-alignment delay values. That's kind of a whole other question, but if you're doing the relative absolute method, then hopefully you're walking into the show already knowing those pre-alignment delay values, or you have access to SubAligner or something similar, some pre-alignment delay guide or something like that. You have your own system for that. But now I know that all this stuff is super simple, right? All I need to know is this subwoofer depth. So I hope this was helpful for you. Let me know what questions this raised. This is all fairly new for me as well, so if there's some way that I could help make this more clear or even more easy to use, especially within SubAligner, please let me know. All right, thanks.